In this video, we will going to learn about logistic regression modeling. So first understand what is logistic regression modeling. Logistic regression modeling is a supervised machine learning algorithm used for binary or multi-classes classification. Unlike linear regression, it predicts a probability value that maps into a range of 0, 1, 1, 0, 0, 1 using a sigmoid function. What are the steps for logistic regression? There are several steps. The first one is to prepare the dataset, then train the dataset, train and test the split, train the logistic regression model, make prediction, evaluate the model using metrics like accuracy, precision, and or ROC-AU. Then now let's understand the explanation of the code. First, we create the dataset. The iris dataset. Here we take an example of an iris dataset. The iris dataset is loaded, and we create a binary target variable to classify set as 1 or not set as 0. Then the second is train test split. Data is divided into training 70% and testing set is 30%. Like 30% for testing and 70% for training. Then model training. The logistic regression model is fitted to the training data. Then evaluation. The accuracy and the detailed classification report evaluate the model's performance. Now understand, uh, first understand what is the logistic regression with a normal example. Then we understand it by the Poisson case. So here is a regression example. So first import the necessary libraries like NumPy, Pandas, sklearn, and all the functions that are present in that which is required in this evaluation, like training underscore test underscore split is used to train the dataset into sorry divide the data into training and the testing phases. Then linear regression function is required, mean absolute error function is required, and mean squared error is required. Then we create a data set. Here our data set name is data, in which we have two columns, hours studied and exam exhausted, which have several values. Then we convert our data into data frame. After this, we define hour study on the x-axis and exam score on the y-axis to draw the graph. Then split our data set into training set and testing set. So this purpose we are using train underscore test underscore split, in which x train x and train text x are the x-axis are the split the x-axis into train and the test, and y-axis into train and the test. Now train the linear regression model by using the linear regression function, and the model dot fit function will evaluate the model. Then make prediction on the test set by using the predict function. Then evaluate the model. So by using the mean absolute error and mean squared error, we could evaluate the model. Then we print the evaluation matrix by using the print function. So as you see, if as I have already executed the code, but if you execute the code, you will get the output like this. Mean squared error is 1.77 and so on, and mean absolute error was 1.77 and mean squared error was 6.13. So in this case, we can find mean absolute error and square error by using regression techniques. uh, Coming back to the our project presentation, now let's understand about the Poisson regression. Poisson regression is a type of generalized linear model used for modeling count data and rates. The dependent variable in Poisson regression is a count. Example, the number of events occurring in a field interval of a time or a space. Here some are the key concepts like Poisson distribution. To assume the response variable y follows a Poisson distribution. There is a function here is a function of performing the Poisson regression, and log links function like Poisson regression uses a log link to ensure that y lambda y is always positive for log y beta naught plus beta 1 into 1 plus beta 2 into 2 and so on. So let's see example of this. How can we perform Poisson regression? So here is an example for Poisson regression. As you can see that I have imported several libraries which are required for it and created a sample dataset. Then convert the dataset into data frame by using a pandas library, and that convert categorical variable to dummy indicator variables by using the pd.getDummy function. Then fit Poisson regression and then print the output and make the prediction by prediction function. So as you can see that the output is like this. If you execute the code, you will get output like this, which says that optimization terminated successfully. Current function value is 1.2 and iteration is 6. The Poisson regression table is look like this. Here we have several variables, models, method, date, time, coverage, convenience, and many other things. And also you can see that there is a age column, claim, vehicle type, predict claim. So in this method you can perform several types of logistic regression. And the in logistic regression, we use key evaluation metrics. They perform vital roles like accuracy defines fraction of correctly predicted instant prediction precision. Fraction of true positive out of all the predicted positive. Recall is the fraction of true positive out of all actual positive, and F1 score is the harmonic mean of precision and recall. I hope you get all this.